All right, Mr. Claxton's Algebra 2 class coming at you here from YouTube to better explain or reinforce what I taught today. Some of us were confused whenever we left class. I don't necessarily like that. So I'm going to try to maybe explain it a little better. Maybe there's going to be something that you can replay here that you're going to see that you didn't see the first time. What we're doing is, aside from seeing the structure in expressions, we're simplifying rational expressions if you want to be fancy about it. Okay, we're simplifying fractions. Just on a basic level, we're trying to make it look easier on the eyes. So you take something like 10 to the 7th divided by 10 to the 12th. We know these are two really big numbers. Okay, and I know that because I have the same base, I could use the properties of exponents. That would be the quotient property that says that I'm allowed to subtract. So I could say it's 10 to the 7 minus 12, right? And that would give me an answer of 10 to the negative 5th. I'm going to show you how to use cross-canceling here. We look at 10 to the 12th a different way. 10 to the 12th power can be written as 10 to the 7th times 10 to the 5th. Understand, you would have 10 multiplied by itself 7 times and 10 multiplied by itself 5 times. If you were to look at that as one long multiplication problem, that would be 10 multiplied by itself 12 times. The reason why I wanted 10 to the 7th is so I could cross cancel it. And understand, that's a really big number that we're just canceling out here. And when we cancel, remember, it's not a 0 that remains, but a 1. Because what we're saying here is that 10 to the 7th divided by 10 to the 7th is the same as 1 over 1. You're reducing that fraction. Just an easier way of looking at it, right? I know no one likes fractions anyway, so let's try to use that word just a little less. What I'm left with here is 1 divided by 1 times 10 to the 5th. Now I'm just going to write 1 times 10 to the 5th as 10 to the 5th. I want to conserve here. I want to be efficient, not lazy. And 1 divided by 10 to the 5th, a lot of people had trouble grasping this next step today. That's 1 divided by a really big number. 10 to the 5th is a 1 followed by 5 zeros. Okay? By the way, I knew what number that was going to be. Normally I would have to work right to left. Okay, in every third one I would have to put a comma. That's 1 divided by 100,000. That's called 1/100,000th. You know that's a very small number. And I've taught you that very small numbers can be written with negative exponents. So we could rewrite 1 over 100,000 as 10 to the negative 5th power. 10 to the negative 5th. And understand, the rule there is, the basic rule of thumb, is that whenever I bring this 10 to the 5th, whenever I bring that up to the numerator, I have to change the sign of the exponent. So that's where it becomes 10 to the negative 5th. Okay, and that's, I can't leave nothing down there, right? Remember, I did have 1 times 10 to the 5th, so really I can still have a 1 down there. It's just 10 to the negative 5th power. You know that. Dealing with this one down here, it is, I desire to have 10 to the 22nd written as 10 to the 15th times 10 to the 7. Now I know 15 plus 7 is 22. If I wrote this out, which I saw a student do today, I would multiply 10 by itself 22 times. I'm trying to eliminate this 10 to the 15th in the numerator, so I can just go ahead and cancel that out. Again, that's like saying 1 over 1. Makes it easy on us. You're left with 1 over 10 to the 7th power. And understand, we're taking 1 and we're dividing it by a really big number. A 1 followed by 7 zeros. I know a 1 followed by 6 zeros would be a million. So a 1 followed by 7 zeros would be 10 million. 1 divided by 10 million. You know that's a very, very small number. 1/10,000,000th. Think about 1/10,000,000th of an inch. 1/10,000,000th of a centimeter. Extremely tiny. You know that can be written as a negative exponent because it's a very small number, 10 to the negative 7th. All right, so looking at these others, I've already prime factored 28 into 2 times 2 times 7. I should have said 2 times 2 times 7 times x. So understand that I'm not completely prime factoring it. I'm using kind of the power rules that we've discussed in the past, the quotient rule, to be exact. So anyway, I rewrite 28 as 2 times 2 times 7. Those are the prime factors of 28. Okay, or that is the prime factorization of 28. I rewrite 6 as 2 times 3. And the reason why I do that now is because I know I have it in its basic form. If it's in its basic form, if it has any common factors, they will show themselves. So again, that's like saying 1 over 1. I don't see any other common factors other than the x's here. And understand, you might want to rewrite that as x times x. And you might want to rewrite this as, that's x cubed, as x times x times x. It may make it a little easier to see that you can cancel 2 of the x's out. When you do that, you only have 1 x in the denominator. So our final answer here is just 2 times 7 over 3 times x. And we all know that 2 times 7 is just 14. And that's 3 times x. So to rewrite this in an easier way, because again, we're trying to make it easier on the eyes, 14 over 3x. And I know that x cannot be 0. I know that x can't be 0 because 3 times 0 would give me a 0 in the denominator. So we usually like to say after a statement such as this, where x does not equal 0. It can't equal 0 here. We have to make that statement because we don't want the board catching on fire. Okay? We don't want to go against those math commandments, right? If you look down here, I've broken 275 my squared. That's not my squared, that's m times y squared over 22 m times y. I've broken that down, and considering the prime factors of 275, I know it's 5 times 5 times 11. Okay, 5 times, and you might do that on some side work, and I know that 22 can be broken down into 2 times 11. I know that the 11s are going to cross cancel. That's what I call cross cancel. Do not confuse it with cross multiplication. That's 1 over 1. I know that one of the m's is going to cancel, and one of the y's is going to cancel. So what does that leave me with up here? Well, I'm left with 5 times 5 times y over 2. That's all I have left down there. And to make that much easier on the eyes, I know that I have 25 y divided by 2. And I really do have to make this statement again because before I started, I could see that I had variables in the denominator, and I know that if m were 0 or if y were 0, that would have given me an undefined state. And I can't have that undefined state, so m cannot equal 0 and y cannot equal 0. So I got to make that statement. Hopefully this helps to kind of clarify some of the examples I went over in class. If not, come back with a question the next day of class. Good luck with your math homework.